we're missing 3, but I'm not going to disadvantage you because they're tardy. Our lab today is going to be a very standard chemistry type of lab. This is the first experience you're going to have using some substances that could be a little toxic, like sodium hydroxide, NaOH. That's pretty much following the naming schemes that we've learned. We said to take first starting on the left-hand column. Now sodium, oxygen, and hydrogen, both sodium and hydrogen are in the first column. So based on what we learned in class yesterday, you wouldn't have known to put sodium before hydrogen, but you have sodium, hydrogen, and then oxygen, but you replace the end of the oxygen with the I, sodium hydroxide. So it reads just like you'd expect. Now, sodium hydroxide is a base. We don't want to be drinking it, so we want to be, a little bit careful with this stuff. So from now on, you shouldn't be bringing any water or food to the lab because, you get that stuff on the desk and then get your hands on the desk and stuff. You don't want to put it in your mouth. So for instance, actually, you should go ahead and put your water up here.
Oh, yeah, that's okay. Or can I slide my backpack?
Yeah. But it's just a standard safety. That's why we have the rule that there's no food or drink in any of the classrooms that have black tables. I don't really say anything about it for the most part until we get to this point, and then I have to. Okay, so what we're going to be doing is testing to try to determine what each of these 9 different powders are. So they're labeled sample 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we have a total of 7 tests that we're going to use to try to differentiate which one each of them is. So you have here the different tests, and I'll briefly talk about each test, and then we'll go over what you need to do. So first, solubility in water. Solubility in water is a test to see if it dissolves in water. If it dissolves in water, is that going to be a physical change or a chemical change?
If it dissolves in water, isn't it a physical?
Okay, we have 2 disagreeing people. So that's great.
Wait, so
obviously one's right and one's wrong, and I'm not saying it's great to have one right or one wrong. It's great to have people thinking about it.
What were the 2? It's a physical change.
Chemical, but if you evaporate the water, can the substance still stay?
Well, if it's a salt, it can. I feel like it'd be a physical change because it's not changing composition.
Okay. The standard answer is it's a physical change, not a chemical change. But you made me think there when you said, if you talk about salt, does salt dissolve in water?
Yes.
Yes. Salt dissolves in water. So salt is one of our substances, and that's going to be one of our tests. When the salt dissolves in water, what actually happens is the sodiums and the chlorines actually separate. They're no longer bound together. So that would be, at the very least, a chemical change as well. But then, of course, as somebody said, if you were to boil it, the water would disappear and you would have salt again. So for our purposes, because this is one of your questions, if it dissolves, you're going to consider that like a phase change. It's staying the same material, but now it's suspended. That's the point we're going to take. If it's changing into a different chemical composition altogether, then it will be a chemical change. So the first test here for dissolving or checking solubility in water, you're going to take a small amount of the substance. So each of you will have a spatula. Make sure that you clean the spatula. Just grab a paper towel. You may say, I have no paper towels. If you open the cupboard, there should be paper towels there. So just maybe moisten the paper towel a little, but clean off your spatula. And I will just randomly take a sample here. I don't know which one is which either, so I'm just going to look for the one that has the most in it for my test. And so I'm going to take the stopper off, maybe. I have the stoppers numbered, so we'll put the right stoppers back in and not cause contamination. A big concern is contamination in your reagents. That is, if we contaminate this stuff, then everybody after you is going to have messed up results. And it says to take about a pea-sized amount. So Just gonna take a little here and say, well, that's a little too little. Try to use your best judgment. That works for me. So I take a pea-sized amount. I'll put the stopper back in here and make sure you clean them before you start. That one I've already started. One thing I didn't do that we all need to do, safety first. Physicists are not nearly as safety conscious as the rest of the world, it turns out. Chemists would have a cow. And physicists are like, oh yeah, I forgot. Okay, now I'm safe. Now we want to put in, it says 5 milliliters of water. So you just get some water. Obviously, you don't want to go too fast or you'll splash everywhere. 5 milliliters is maybe about halfway filled. So I'm going to about halfway fill this with water. Okay, that was too much, but say lovey. I'm not going to dump it on. I'm just going to go with that. And then you want to do this for about a minute. A minute of mixing that you do like, this is what the chemist told me is the best solution. The textbook says to go like this, or the guide, but he said his experience is going like this works better. But we want to do it for about a minute, right? Not just, oh, I've done it for 10 seconds. Do I see anything happening there? And after a minute, you want to say, does it look like I have it all dissolved? Does it look like it's partially dissolved? Or does it look just the same amount as it was when I started? And so you're going to look at that, and you're going to say, which one is it? So I've not waited long enough, but you would make a judgment. You say, does that look like it's dissolved? Yes or no? And then you have this sheet here that I printed out for you that I want you to report or record the result of each test you do. Now, you don't have to do all of the tests on all of the substances, but the first one you're going to do on all the substances is this one. And so I've done this test, and then I'm going to report here, okay, so this is sample 7. Make sure you know what sample you're working with. And I tried to dissolve it in cold water, and did it partially dissolve? Did it completely dissolve? Or does it look like nothing happened at all? And so with this one here now, of course, I didn't pay close attention to how much I had in there because, I'm thinking about now, what am I going to do next? What am I going to do next? But I would need to record what happened. Based on what happened, you're going to go on to a different test. So we have a couple of different tests. The tincture of iodine test is one used for any unknown that is insoluble in water. And so I'm going to go ahead and say, I think that one was insoluble. And actually, I'm probably wrong. It looks like it has dissolved a little. But that's okay. I'm just going to pretend that it didn't dissolve at all. And so for the tincture of iodine test, you can see up there the number 2. It says, add a few drops of tincture of iodine to the unknown as it sits undissolved in the water. So you would do that right after you did the test, if that's your flow chart. Now there are 2 that you can do right after. Which one's the other one? Yeah, the next one, the phenolphthalein. If it is soluble in water, you do the phenolphthalein next, is the natural thing to do, because then you can just do the second test using the same test tube that you used for the first one. So I'm going to take my tincture of iodine. Now the tincture of iodine, you notice it has its own little dropper taped to it. Use that dropper with it. The other ones, there's a dropper behind them, and just take the dropper out of there, use it, and then put it back in the little beaker. So I'm going to take some of this tincture of iodine, and of course you get this on your finger, it'll stain your fingers. Pull up a little, put a couple drops in. And that iodine smell reminds me of working at the dairy. And now I look at this and I put the iodine in and add a few drops of iodine to the unknown as it sits undissolved in water. A deep blue color forms as the iodine complexes with cornstarch. The brownish color will appear for all others. Well, I can pretty clearly say this ain't cornstarch, right? Because it just stayed brown. It hasn't done much mixing here. but it stayed brown. There's been no bluing at all. And so I'd say, not cornstarch. And so I'd record that in my table. So number 7, I did one, and like I said, don't take this to the bank because I wasn't careful. But I said non-soluble, and so then I did the iodine, and I'd say, did turn blue. That's a negative test. So actually what I would put is brown, right? Because that's the 2 outcomes, blue or brown. Whoops, don't do that. Now, the next thing. For all of the stuff we're using, I am pretty sure that Ken said we can wash it down the sink. Disposing of chemicals is always something we need to be careful with. But we are not using anything that is problematic as far as I know. So, want to make sure you're running water down the sink. And then pour it down the drain so we don't get residues in the sink. Pour it down the drain, rinse it, pour it down the drain. You're not going to use the test tube again though, so just set the test tube aside and go on to the, actually now I think about that, we could use the same test tube for the same material if you're doing another test on the same material, which of course at this point I would be because I have one more test I would need to differentiate it. But don't use the same test tube when you go from sample A or sample 1 to sample 2. Because you don't want to have any kind of cross-contamination there. Okay, so we've looked at the first 2 tests. The third one is the phenolphthalein test. This test may be used for any unknown that is soluble in water. So if it dissolves in water, then you could use this one immediately after you did the water solubility test. And so it's just like what I did for the iodine, except for I'm going to put a drop of phenolphthalein in. Phenolphthalein being this one here. Notice that it says it's 95% ethanol or 190 proof if you were going to talk about, liquor. It's highly flammable. Obviously, you don't want to drink it. Just because it's 190 proof does not mean that it would be something that would be a good liquor at all, because that phenolphthalein, I believe, would make you sick. So, don't need bad ideas. You put that phenolphthalein in, and we'll learn later about acids and bases, but the phenolphthalein will change color based on the pH. And so that's the next test. It will either be bright pink if the solution is alkaline, or it will be a medium peak for one and light peak for the next. So you're going to judge the color with that one, with the phenolphthalein. And it tells you how acidic it is and helps you to separate your samples. Now, the other samples, the white vinegar, add a few drops of vinegar to the unknown. It says in either the dissolved or undissolved state. I think it's actually easier to have it in water. Have some of your sample in water, and then you put this in. And if it bubbles, then that means it's the chalk sample. And so you just look for that bubbling. I said we better look up here to make sure I'm right. No, there's more than one sample that has calcium, that has carbonate in it. So it's not just the chalk sample. So it's positive for the chalk sample, the washing soda, and the baking soda. Notice all of those have CO3 in them. And what you're having is a reaction with the CO3 making bubbles. And so you look for the bubbles. If you see the little bubbles coming up, you say, aha, it's one of those 3. Then the next test, the sodium hydroxide test, is one that only tells you if it's magnesium sulfate. The rest of them it will be useless on. So it's telling you if it's Epsom salt, if the unknown dissolves in water and is insoluble when treated with the sodium hydroxide, then the unknown contains magnesium sulfate. So you add some sodium hydroxide in, and if when you add the sodium hydroxide it precipitates, that is, it separates back out, then that's the test that says it's magnesium sulfate. Next, the last 2 are very similar. Hot water. I have this water here that I am, overheating. It's supposed to be maintained at 60 degrees. I'm now up to 70 Fahrenheit. And so you're going to do the solubility test again with that hot water. Now, this is hot water. You don't want to be dipping your finger in it. Right? For a short time, that can burn me. But overall, it probably wouldn't be good. So I just have a little dropper here. So you're going to do just like you did for the first one. Put your little pea-sized sample, and then just take the dropper, drop. Well, this one's great. The rubber is broken on this one. I'm just going to throw that away. And fortunately, we have more droppers, so I'll just grab another one. I had that one because it was the largest. So I'll just put my hot water in here. It'll take a few very annoying fillings of this, but you fill about halfway with the hot water, and then you once again mix it for a minute and see if it dissolves. If it did not dissolve in water and it dissolves in hot water, then you know that it's going to be the sodium chloride. Other way around. All the water soluble unknowns become more soluble in warmer water except for sodium chloride. So if it changes when you make it hot, then it's not sodium chloride. If it doesn't change when you make it hot, then it's still sodium chloride. So that goes back to, the solubility. You need to note how much you have when you start. So if you're checking to see if it dissolved, you'll probably still have some at the bottom. But if you have there's only half as much as I started, then half of it dissolved. So, the solubility is something you're going to be testing, and it's not going to completely dissolve probably. So you have to make sure you know how much you started with, which I didn't check. When I did the first one, I wasn't very careful on that. So it was not definitive. You can't say, oh, well, he already did sample 7 with water solubility because I didn't do it right, because I didn't check carefully. Okay, the final one, rubbing alcohol. The rubbing alcohol test is just like the water solubility test, except for using 70% isopropanol. It does say you put in about 7 milliliters, which would be pretty much filling up to maybe a centimeter from the top of your beaker when you're using this. And I thought I had I guess I'm just trusting you to pour this. Be careful, don't spill everywhere. So those are the tests you're doing. Now, what's our goal? Our goal is to determine what the names are for each one of these. So before you start, you need to have a plan. What we don't do is run every test on every sample. We run only the tests necessary. Now, I will warn you, don't say, well, I don't need to do test B because I already have identified the sample that test B would have identified, because you could have made a mistake in interpreting your result. So do run through all of the tests you need, even if your order says, well, I've already found this one, so after running test A, it has to be this. But we don't want to run extra tests that would not be called for. So the first thing you need to do before we get started is, based on the information in this table, make a flow chart of how you're going to do some testing. So Alex has really helped you out with how to make a flow chart. Except for Alex's flow chart is kind of goofy. Because Alex's flow chart, can you lick the science? You actually go through and you're breaking down to the subcategory, and then he has only in theory can you lick it in psychology. In quantum mechanics, both yes and no. Yeah, that's Alex's flow chart. Over here as a starting, your flow chart should start like what I have here. So I'm going to go back to the tablet and work my way through how I got there. But the first test should definitely be, is it soluble in water? So you're going to start your flow chart by having, here's all of my samples. So we have all of the unknowns, and I'm just going to put unknown here because I just know it's one of the unknowns. And the first test I'm going to do, and I'm going to go ahead and make this, so I put water solubility. Now, there's really 2 outcomes that we're looking for. either it's soluble or it's insoluble. If you look in your lab guide, at least if your lab guide's the same as mine, there's a typo. What does it say?
I don't know if we're doing too silly.
It has 2 solubles and no insoluble. Try to be a little more careful than the lab guide was. So if it's insoluble in water, then we can look over here and say, well, which ones were insoluble in water? Cornstarch, white chalk, or plaster Paris? Just use 2-letter abbreviations for each of these. So if it's insoluble, we know we have one of those. Cornstarch, white chalk, or plaster of Paris. If it was soluble, we have a much bigger selection here. We have the washing soda. Yes, sir.
Are you trying to make it so they can see what's on your tongue?
Yes, I am. Why did nobody say, hey, you know, I don't see a thing you're writing?
I thought it was like you were trying to scrub the board or something.
Epsom salt, baking soda, boric acid, salt or sugar. I use salt and sugar for the last 2. So here is what I have so far. My first test with 2 possible outcomes, soluble, boom, or insoluble the other side. Then I have to decide, what am I going to do for the next test? Well, let's focus on the insoluble. We only have 3 things, and there's only 2 more tests for the insoluble ones. If we look at our table here, we have the iodine and the vinegar test. Which one should I do next? Well, let's look at what you have to do. The iodine test you can do in the water. So this is going to be while it's sitting there in the water, as it sits undissolved in water. And the other one was the white vinegar test. Add a few drops of white vinegar in the dissolved or undissolved state. Both of them can be done in water. So it does not matter which one you choose to do next. They can both be done in water, and they are both going to give you, they are both going to give you a 1 in 3. The iodine has this one that responds. The vinegar has that one that responds. So you choose which one you want to do next. So that's up to you. I am going to simply make an arbitrary decision here to say I'm going to do the iodine test. And so with the iodine test, I have 2 possible outcomes. I have either it's positive, and with the iodine test, positive meant it turned blue. And if it turns blue, if it's positive, then that means that it must be cornstarch. So I'm done with my testing if it was cornstarch and it turned blue in iodine. On the other hand, it could have stayed brown. And if it stays brown, then I have one of the remaining 2. So I have either, well, actually, could have just looked right here. I have either white chalk or plaster of Paris. And so then I have to choose another test. Well, there's only one more test to do, and that's going to be, actually, I'm going to make my arrow go this way this time. And so that's going to be the vinegar test. Go away. The vinegar test, and the 2 possible outcomes are I'm trying to make this all pretty colors, but I'm getting lost in the white chalk and plaster Paris, and I just have to check which one's going to do which. So the vinegar test, the white chalk is the one that's positive. And what does it mean to be positive for the vinegar test? No, the vinegar test is the bubbles. So the white chalk will bubble. So there's the complete flow chart on the right-hand side for the insolubles. Now for the solubles, you have to go through and figure out the order you're going to do for the rest of them. Remember, you could have reversed the iodine and vinegar test orders and it still would have worked. It's just going to have different outcomes. For the soluble part, you need to decide, okay, what test do I want to do if it was soluble? So all of these are soluble down here. And then I want to look and see what's going to give me the closest to a 50-50 split. So if you take the pH test, that has a 2-to-4 split. If you do the vinegar test, it has exactly the same 2-to-4 test. You know what that says to me? It says you should never have to do both test 3 and test 4 to the same substance because you have the same outcome, right? They test for the same thing. So I would never use the vinegar test because I think the light and medium pink is easier than the bubbling. So I would not use the vinegar test on these. I cross it out just to make sure. Now this one here is a 1-to-5 ratio. This one here is really kind of a 1-to-5. So you say, what's the next test to take? Which one is going to have the biggest selectivity of the tests remaining? 3, 5, 6, or 7? Yeah, 3 has a 2-to-4. That's your biggest selectivity of these remaining tests. So you would do that one. So you'd have either one of these 2 or one of these 4. And then you say, well, if I did test 3 and it turned pink, then I'm going to look for the hydroxide because the hydroxide, whoops, not the hydroxide, that's the wrong one. This is actually, you actually have to grade the pink, really. You're basically done with that because look at the others. There's no difference in these 2. There's no difference in these 2. And there's no difference in these 2. And, of course, there are no difference in these 2. So, actually, those 2 were specific. If it turned a light pink, it was baking soda. If it turned a medium pink, it was washing soda. And so you actually are done with those 2 after doing test 3. And then it's just the other 4 that remain. And then for the other 4, test 5 would test for Epsom salt. Test 7 would test for boric acid. And then you have the grades in test 6 to help you differentiate. So what you need to do is make your entire flow chart of I'm going to do this test with this outcome, then I'm going to do this test with this outcome, I'm going to do this test until you have a plan that's going to tell you what each sample is. So put that flow chart on the back page of your, where you're doing it. Perfect. Because that's where Alex is going to look for grading. When you have your flow chart done, bring it up to Alex for him to look over so he can just tell you, yeah, that seems like it'll work, or, ooh, it looks like you forgot this. And then start doing your actual tests. Make sure you wear your eye protection. Make sure you clean these things off and do everything you can to avoid cross-contamination. Make sure you use the right dropper. And be safe. Don't drink anything. Any questions? Okay, groups of 2. We'll get started.
Am I supposed to fill out that chart too?
Yes, but that's for the results of your test. And so you're going to use that chart then to determine which sample was which one. You have there in that tab. Here is the end. Of course, you can see you're saying which sample was each one. So cornstarch was, and you're going to put 1 through 9 for each one. And then which test measured physical properties and which measured chemicals. So you're going to have, physical on one side, make sure you specify, and chemical on the other. A question that I answered in class yesterday, sugar is a chemical, but it's also food. Is this contradictory? And then finally, counting up how many tests you took. So your chart will have a result for every test you took. So you can just count up the places you marked in your chart for, that is this chart here, to determine how many total tests you had to take. And that's your recording here. I think Alex and I came up with the number 26.